Hello everyone, welcome back to my channel. In this video, we are going to discuss about the qualitative analysis topic, and we are going to discuss a question which is based upon the SWOT analysis. Right now, in my observation, I have seen that in many of the past year questions, the SWOT analysis topic is being asked in the form of comprehension. So they will ask you a comprehension, and 2 3 questions will be there, and if you can easily solve the comprehension, all those 2 3 questions can easily be solved, right? So basically, to understand the SWOT analysis, you don't have to mug it up. You have to learn it. You have to understand the basics of it, and yes, a little bit of, not we can say cramming, but memorization of the reactions actually takes place, right? So let's go to the topic and let's see how to solve this question. Now the question says we have a metallic chloride X. A metallic chloride X is there, and it shows the following reactions. Now when this metal chloride is passed through H2S gas, or we can say when H2S gas is passed through it in acidified medium. Now the first hint which is available to us is that we have H2S gas in acidified solution. That means this metallic salt, this metallic chloride, belongs to which group? It belongs to group 2. Why? Because the group 2 reagent which is we used here is H2S in acidic medium. So basically it is what? This H plus is basically, we can say, HCl, right? And this is the reagent of group 2. So when this metallic chloride salt is passed, or we can say when the H2S in acidified solution is passed through metallic chloride solution, we obtain a black color PPT. Now in group 2, the salts which give us the black color PPT, basically what happens? Any salt, metallic chloride X is there, right? So the charge on X will be what? Now X can be X2 plus, or X can be X2 plus 1, right? So basically if you look at the group 2 elements, if you look at the group 2 reagents, group 2 ions, most of those ions are plus 2 ions, right? And plus 3 ions. So if this plus 2 ion reacts with S2 minus, it will give you what? Sulfide salt, XS. Now the question is saying the color of this XS salt is black in nature. So what are the black PPTs which are involved in the case of group 2 reagents? These are HES, mercury sulfide, PBS, CUS, and Bi2S3. These are the 4 precipitates, sulfides, which are black in color, right? So we have to select one of them. Now second point says that precipitate obtained in the step 1. Here in step 1, these are the precipitates obtained from step 1. The precipitate obtained in step 1 is not soluble in yellow ammonium sulfide, right? Now we know this thing, that the group 2 group 2 ions, group 2 basic radicals are classified into 2 categories based upon their solubility in yellow ammonium sulfide, right? So those who are soluble in yellow ammonium sulfide are they are Hg2 plus, right? Those who are insoluble, one is Hg2 plus, Pb2 plus, Cg2 plus, Cd2 plus, and Bi3 plus. These are insoluble in yellow ammonium sulfide. They are insoluble. And the remaining ones are what? Remaining ones are soluble, and they are classified as As3 plus, that is arsenic, antimony, Sp3 plus, Sn2 plus, Sn4 plus, As plus 5, arsenate, right, and antimonate plus 5. These are the ions. These ions are actually soluble. They are soluble in ammonium sulfide solution, like this. Now the question is saying what? The precipitate obtained first one is not soluble in yellow ammonium sulfide, right? That means it belongs to what? It belongs to this group. It belongs to this group of ions. So we have to select one of them. Now the point is, it is black, okay? The precipitate, the ion is black in nature, and it belongs to the group 1. It belongs to this group. And if you see Bi2S3, that means we can cut CDS, cadmium sulfide can easily be removed, because actually cadmium sulfide is of yellow color. The cadmium sulfide which we obtained is of yellow color. Next point, it says that when the solution of stannous chloride is added to aqueous solution of X, a white precipitate is obtained. A white precipitate is obtained, right? That means that this third option, this third statement, is basically a specific reaction which belongs to Hg2 plus ion. It is a specific reaction which belongs to Hg2 plus ion, right? How? Now simple point is there. Hg2 plus ion is there when we add the group reagent, that is H2S, in acidic medium, right? What will happen? We will obtain HGS, which is black precipitate. The color of silver sulfide is black in nature, right? Second point, when the solution of stannous chloride is added to the aqueous solution of X. Now mercury available here is of +2, right? Oxidation state. When we add stannous chloride is basically SnCl2. Now tin with the +2 oxidation number, basically act as reducing agent here. So it will reduce Hg2 plus from here to Hg plus 1. This one. It will reduce this one and itself undergoes oxidation and it will form SnCl4. Right? It will form SnCl4. So basically this Hg2 plus is basically what? It is HgCl2. It reacts with SnCl2 and it forms Hg2Cl2 plus SnCl4. If you see here, this is the dimer form of HgCl, right? This is the dimer form of HgCl where the oxidation state of mercury is +1. But the reaction doesn't stop here. Now this is white precipitate. This is basically a white precipitate. The reaction doesn't stop here. Now what will happen? Whatever Hg2Cl2 is produced, as I have told you that SnCl2 is a good reducing agent, it will reduce the +1 oxidation state, right? It will reduce the +1 oxidation state of mercurous ion here into further 0 oxidation state. It will make it in the form of Hg plus SnCl4. It is again a precipitate in the form of black color. Understood? So now what is it saying? The solution of stannous chloride is added to the aqueous solution of X. We obtain the white precipitate which turns grey on addition of more stannous chloride. So basically this black color is also what? Dark grey. So it has the appearance of black color only. So this is the reaction which is taking place in the case of third statement. Next comes fourth statement. The fourth statement says when the aqueous solution of Ki is added to the aqueous solution of X. That means in this HgCl2 salt, when do we add Ki? Now when we add Ki in the solution, what will happen? Again same ion exchange reaction takes place and we will get HgI2. Right? This color of HgI2 is scarlet color. It is scarlet red. Right? What is the statement saying? A red precipitate is obtained. So yes, it is a scarlet, which dissolves on the addition of excess of Ki. So now if I add excess of Ki in the HgI2 formed, what will I get? We will get K2 HgI4. Right? It is a complex, a very famous complex, very important one, right? Which is also called Nessler's reagent. And its color is red only, brownish red. Right? So these are the reactions which are particular to this question, particular to this ion, that is Hg2 plus. Right? What is the X here? So X here is Hg2 plus ion. Or we can say if it is chloride, the X is HgCl2. This is our X molecule. Right? First step reactions are where we obtain the black precipitate of X. So this is the first step reaction. Then second step reaction where it is not soluble in yellow ammonium sulfide, that we have already predicted that how we do it. In third case, when it reacts with stannous chloride, These are the two reactions which are available for the second case. And finally, when aqueous solution of KI is added, in that case the reaction set available is this much, right? So these are the reactions which are peculiar to the estimation, or we can say the qualitative analysis of He2 plus ion. So I hope you understood the question properly. We'll keep on solving more questions on the salt analysis because it's a very important topic for JEE Advanced. So keep watching the channel, keep liking the videos, keep subscribing it, and stay tuned for the next problem. Thank you.